Okay, last page. So Mo, Zane, Teddy didn't complete many homework problems during the first month of school. As each month passed, they completed the number of problems in the chart below. Okay, A, would y equals 4x plus 40 be an acceptable model for this situation? Alright, so the first thing I want to do is look at this and see if I can identify a pattern. So is it multiplication? It could be times 4, 40 to 160 times 4, 160 to that is times 4. So if I know the pattern is this, that's a common ratio. So I know it's exponential. Alright, so would this be an acceptable model? No, this is linear. So no, because the data represents an exponential model. Okay, if the answer to the part A is no, what is the correct model to represent the number of homework problems that Mo, Zane, well, we just said that, expo. Oh, and it actually wants me to write it out. That's my problem. All right, so y equals my initial amount, which is 10, times 4 to the x power. All right, my 4 is my pattern, my 10 is my initial, and my x is my variable. Okay. Taishe bought a house for $185,000 in 2007, but unfortunately the value of house has been decreasing by 4% each year. What kind of function will model this situation? All right, I know that it is decreasing by 4%. All right, so if it's decreasing, it has to be an exponential decay. Okay, now I want to write the function that fits the situation. All right, so this is a little bit tricky, but I know that 4% is 0.04. Okay, and if I think back to when I had decay, I would always use 1 minus b as my thing. All right, and I would get this number, this rate. So what I want to do is 1 minus b equals 0.04. Okay? So 1 minus b would normally give me this rate. So now I'm going to just plug this in to find my b. So I'm going to minus 1. Okay, and I get negative b equals 0.96, negative, divide by negative, and b equals 0.96. Okay, so when I want to write my equation, I know that y equals my starting amount, 185, times 0.96x. Okay, so it's like working backwards. All right, now let's try 23. Okay, so the wait time at Space Mountain starts at 10 minutes but increases by 5% each hour. Okay, write a function that will model this situation. All right, so I know that this is going to be exponential again. Okay, so what kind of model is represented by this situation? I'm going to skip to B. I'm going to write exponential. Okay, write a function that will fit this model. So again, remember, if it's 5%, I need to move that decimal place over 2, and I get 0.05. So that's my rate. All right, opposite of decay, this is growth. So I should do b minus 1, and that's going to give me my 0.05. All right, so I'm going to add 1. So b equals 1.05. Okay, so my function is y equals 10, my initial value, times 1.05 to the x power. Okay, explain why y equals this is not a reasonable function, because this is a quadratic model, and the situation represents an exponential function. Okay? Alright guys, that's it. Good luck.